P-H-Y, 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 P-H-Y. Physics. Welcome!
Welcome to another AP Physics Camp lecture. Today we're going to be reviewing vectors and scalars. No, Alex, not Vector from Despicable Me, nor that other guy called, I'm guessing, Scales. Let's try to focus on physics instead, which is why I'm referring to quantities, not supervillains. All right, let's take a look at the definitions for scalars and vectors. Scalars are quantities that have a magnitude, such as time, mass, length, or distance. Now, vectors, on the other hand, are quantities that have magnitude and direction, such as displacement, velocity, acceleration, force, and many others. Yes, Alex, I guess that's one way to remember the definition, but just make sure that you do know the difference between the two. Good question, Alex. Notice the major difference between the two is the presence or lack of direction, in which vectors have direction, which means that the values must be accompanied by a form of direction either illustrated in a descriptive form, such as north, south, east, west, or maybe right, left, down, up, but oftentimes they're actually illustrated using a negative or a positive sign. Yes, Alex, for the purposes of this class, we're going to stick to one conventional rule in illustrating direction, in which down or left are negative values and up or right are positive values. That's right, Alex. We do the same for north and south being opposites, so we label north as positive and south as negative. Then for east, we label positive and west as negative. Yes, you got it, Alex. The reason we use this rule is because it is transferable from math class, in which you will see positive and negative values on the y-axis, similar to saying up and down or north and south. Then you also have positive and negative values on the x-axis, similar to saying right and left or east and west. So in physics, you must remember and apply this rule when illustrating the direction of a vector. Another thing that you must take into consideration is that scalars are very easy to combine due to only consisting of magnitude, in other words, a number value. But when you are dealing with vectors, things get a little bit more tedious. Let's first review a scalar scenario. Let's say that your dog finds a hole in the fence and sets out on an adventure. Sure, Alex, the dog's name can be Candy. But let's try to focus here. She travels 2 meters, then decides to rest for 2 seconds, and then travels 8 meters, and finally 3 meters. What was Candy's total distance that she traveled in this adventure? Yes, Alex, that's right. She traveled a total of 13 meters because she first traveled 2 meters, then plus 8 meters, and finally plus 3 meters, which totals to 13 meters. So what would be the magnitude of this scalar? Yes, Alex, you're right again. It would be 13 meters because magnitude is referring to the amount, basically the numerical value found in this measurement. But what about the 2 seconds? Right again, Alex, the 2 seconds was actually extra information that you didn't need to know in order to calculate the total distance traveled. Okay, let's try another scenario. You decide to go to the gym and notice that there is 3 different colored medicine balls, which is red, that is labeled as 9 kilograms, yellow, and it's labeled as 22.7 kilograms, and then green, which is labeled as 15.9 kilograms. Now, you see your instructor, and your instructor advises you to obtain the medicine ball with the greatest magnitude. Which color medicine ball would you use? That's right, Alex. The yellow medicine ball does have the greatest magnitude because it has the higher number of mass between those 3. Glad you asked, Alex. Let's take a look at the following scenario to answer your question. Let's go back to your dog Candy as an example. Let's say that she decides to take another adventure by jumping the fence this time and setting out to explore the neighborhood. She starts off at your house, which is located here, and then decides to walk 3 kilometers north, then walks 4 kilometers east, then 2 kilometers west, 7 kilometers south, 9 kilometers west, 1 kilometer north, and lastly 3 kilometers south. My question is, how far away is Candy from your house? So, how do you begin to figure this out? Not exactly, Alex. If we were to add up all of these values, that would actually just tell me the total distance that Candy traveled, but not exactly how far away she is from your house since she took different directions. So in order to account for this, what type of quantity are we working with if there is magnitude and direction involved? Yes, that's right, Alex. We're working with vectors, and in this case, we are given 7 different vectors. Yes, we could do that by combining all of the vectors going north, all of the ones going south, and then all of the ones going east, and all of those going west. But we would still have 4 vectors with different directions. So how do we combine those? That's right, Alex. So in this case, vectors in the north direction can be expressed as positive values, and those towards the south in the negative values. And the same goes for east and west. Okay, now what? That's exactly right, Alex. Let's combine north and south, which are essentially all of the vectors on the y-axis. That gives us -6, which means Candy traveled more towards the south. Okay, so what about east and west? You got it, Alex. These vectors are on the x-axis and they are opposite directions, meaning east is positive, west is negative. And when we combine them, we get -7, meaning that Candy traveled more towards the west. So we now know that Candy's adventure took her 6 kilometers south and 7 kilometers west. In other words, she traveled southwest of your house. But how far? You're absolutely correct, Alex. These two vectors make a right triangle because when we add vectors, we're actually combining them using the head-to-tail technique, in which I drew the -6 vector pointing south. From the arrowhead, I began to draw the next vector, which was -7 pointing west, in which the arrowhead is here, and here is the tail, which is why we say that we're adding them from head to tail. And you get this right angle in this case, which means that we can find the resultant vector, which is basically the combination of the y and x component vectors that we have here as Candy is moving in the southwest direction. So how do we find the length of this missing side of the triangle? Great idea, Alex. We use the Pythagorean theorem to solve for the missing side, since we are working with a right triangle. But what do we label the side that is missing? That's right, Alex. The longest side of the right triangle is the hypotenuse. Therefore, it is labeled as C. And the other 2 sides are A and B. Okay, let's plug in our values in which A will be -7, B will be -6. Notice how I could have labeled them the other way around, and it wouldn't matter as long as they are identified as either A or B. Now that we have them in our equation, how do we solve for C without the exponent? Glad you remembered, Alex. To eliminate a squared, we must square root on both sides, which means our equation will now read square root of 7 squared plus 6 squared equals C. Notice how you are square rooting everything, which means that you should first solve what is inside the parentheses. Great job, Alex. Now we need to add these 2, and that gives us 85, which means we must get the square root of 85 to solve for C. You did it, Alex. We solved for C, meaning that now we know that Candy traveled 9.2 kilometers southwest of your house. Okay, but let's say that I wanted to get more specific in the direction that Candy traveled by using a compass, and I asked you to tell me the degree in which Candy moved towards. How would you figure that out? You got it, Alex. We would use sine, cosine, or tangent. But how would I know which one to use? So it's actually a trick question because you technically could use any of these depending on what sides of the triangle that you want to use and the angle that you're solving for. For instance, we want to know the degrees south of west that Candy traveled. So that means that I'm looking for this angle right here since it's moving towards the south from west. But notice that this angle is not inside of that triangle. So how do I solve for it then? Yes, that's right, Alex. This angle is the same as theta 1. And this other angle is the same as theta 2. Which means if I find out theta 1, I basically know what this other angle is. Okay, so based on theta 1, the y-axis side of the triangle is opposite to theta 1. And the other one is adjacent to it, which means I can solve for theta 1 by either using inverse sine of 6 over 9.2, which is opposite over hypotenuse, or inverse cosine 7 over 9.2, which is adjacent over hypotenuse, or inverse tangent of 6 over 7, which is opposite over adjacent, as you mentioned before using toa. So in reality, we can solve this angle using any of these functions. However, I would personally pick tangent, just to make sure that we eliminate the possibility of error due to our calculated hypotenuse. But again, you could use any of these functions. Okay, so let's try this out. Inverse tangent of 6 over 7. Good question, Alex. You need to keep in mind that tangent is only used when you have the angle and you are solving for the missing side, such as this. Now, the inverse is used when you are missing the angle and you know the required sides of the triangle, such as this. Now, keep in mind that in order for you to get rid of that tangent, moving it to the other side and leaving the theta by itself, you need to do the opposite of it. And that's where the inverse tangent comes in. So that eliminates the tangent, inverse tangent, and now you're left with inverse tangent on the other side. Great job! This actually means that Candy traveled 9.2 kilometers at 40.6 degrees south of west from your house. Yes, Alex, Candy would definitely need a nap after her adventure. This concludes our video lecture. Make sure that you took good notes, and that's it. Have a great one.